Algebra 2. I gotta be honest, I'm a little bit giddy here because we're starting Algebra 2. This is the big one. My name is Mr. Kelly. I am at Baumholder High School. What I'm going to do is introduce all of your teachers because we have a lot of new students. This is, I'm Mr. Kelly right there, and these are my two daughters, Kira and Sophie. This is Mrs. Kelly, Connor, and Max. And we have been at Baumholder for 13, going on 14 years. Whew, only feels like 50. Next up is Mr. Bean, and he is at Ramstein High School. Now, I would introduce all of his family, but we don't want to be here until Friday. The thing about Mr. Bean that we don't know is he's a closet Baumholder lover. He is secretly in love with Baumholder. Next up, Mr. Bruss. He's at Ramstein High School. Now, he used to be at K-Town, and then he moved to Ramstein. I don't get this thing. But anyways, that's Mr. Bruss with his family. And lastly, we got Sully. We call him Sully. His name's Mr. Sullivan. He's at Kaiserslautern High School. He, like Mr. Brust, are both from Ohio. That's a very important thing. I feel sorry though, because he's a Browns fan. All right, so what I'm going to do is I'm going to remind you of some things. You have your note packet, and you have the left-hand margin. Those are to write down your questions. You already know that. Okay, we have a summary at the end if you're doing Cornell notes for your Avid class, or if you're just a good student. I mean, that's the way that works. And what you need to do is pause the video. If I'm going to talk fast, I'm talking fast now, but if you don't get something, pause the video so that you can hear it again, go back and listen to it, and make sure you write down everything that we put up here on the screen. And if you haven't noticed yet, I got a little guy over here that he's telling you that if you really don't get this and you need further instruction that goes really intensively into detail, then you can go back to Algebra section 1.1. That's where Sully introduced this. He introduced us to the order of operations and GEMDAS. Now, most teachers use PEMDAS. They go around and they say parentheses, exponents, multiply, divide, add, subtract. We, however, are going to use GEMDAS, grouping symbols, exponents, multiply and divide. At the same time, those guys are tied as well as add and subtract. They're tied. So you're asked, why did our other teachers teach us PEMDAS? Well, the honest truth is they didn't have to deal with all these ugly looking things. And we do. All right, so before you've never had square roots of fractions where the square root's actually a grouping symbol. You have to do underneath the square root first. And these ugly fraction bars, you have to do the numerator first here. Even though there's parentheses, even though there's exponents, there's some, they're like invisible parentheses around the whole top and the whole bottom. You'd have to do that first. So, enough of GEMDAS. So let's start with the first actual problem that we're going to figure out here. It says the directions say to evaluate. Okay, so we're going to evaluate k plus 6 times the quantity h plus j. So what I'm going to do to help us out here, I have some fancy smartboard tools. I'm going to use k, and I'm going to put a little yellow dot where that goes, and I have fancy green dots, so we're going to use that for h, and we're going to put that right there, and we're going to use fancy purple, because purple's awesome. And we're going to put purple right there. All right, so that's where you substitute each one of those. You put the H into the H and the J into the J, but I'm already telling you guys too much because you've done this 100,000 times. I'm going to substitute in for H, which is -6, by the way. Why do I have to use parentheses all the time? Okay, and look, I'm substituting in for J. Why am I using parentheses there? And the answer is you should always use parentheses when you're subbing in a negative. Now, the reason why, kids are smart, you always want to know why something. So let's go to our fancy calculator here, which I know all students love the calculator. Mr. Bean loves the calculator. Ask it to the prom. Anyway, it got turned down. But if I put in -2 squared, you're looking at -2 squared. That should be what? -2 squared. If I put it in like this, it gives me an answer -4. So some part of your brain should go, hold on a second. -2 times -2 is not -4. Why do we get a -4 there? Let's try it with parentheses. And the answer then becomes +4. All right, so this is the proper way to do it. Well, you're asking why. It has to go back to GEMDAS. GEMDAS says you do grouping symbols, you do multiplication. Okay, how does it? Grouping symbols, exponents, multiplication. So what do we have here? We have a negative. And what is a negative? A negative is really -1 times. Okay, it's the opposite of, and then we have to do the exponents first. Okay, you always do exponents first. There's no grouping symbols here. So you'd have to square the 2, get a 4, and then you make it negative. That's why this equals -4. Okay, in the next example, when you put it in parentheses, we're not talking about a negative term. We're talking about -2, which is a negative number, and you square that. And then -2 times -2 is +4. So all of that explanation with a fancy calculator to get you to the point where you use parentheses when you sub in a negative. That's very important because you will screw it up. Now, some of you get it now and you're like, I'll remember, and all that kind of stuff. No, you'll screw it up. So please just do it this way. All right, on with the problem, because we're subbing it out here. I'm kind of talking off to the side as I'm doing the problem because I know a lot of you can do this problem. It's the same stuff you've been doing, I think, since 8th grade. I believe 8th grade is when you do this stuff. You multiply before you add. The first answer will be negative 49. All right, number 2 here. We're going to sub in. No more colors because we're past that. So we're going to get 2 minus parentheses. We have an x here, so we're going to do negative 6. I'm going to put it in parentheses, plus we get a 3. I don't need parentheses because it's positive, but if you want to put them, you can. It's not going to hurt anything. And we're going to get 2 minus, I have to do grouping symbols first because we're using GEMDAS. So let's figure out the inside here. So we have negative 6 plus 3. Hopefully you know your integers. That's negative 3. We have subtraction and we have an exponent. So we have to do the exponent first. So negative 3 times negative 3 times negative 3. That's going to give you a negative 27. And again, look, I'm using parentheses so it's really clear what I'm doing. If I don't put the parentheses and I write it like this, 2 minus negative 27, okay, I kind of get that, but you know, these things can blend together and people can get confused. And no, I don't like that as much as I like this one because now I have minus a negative number. My brain says, oh yeah, remember what to do there. We're going to get 29 for this. Okay, so I did the first 2. You guys pause the video right now. You really got to pause it, and you do the next 2. Go. All right, let's see how you did here. Now, the part that I would be careful of, I'm going to warn you right now. We have a minus, and you have to sub a negative 2 into B. So it should be minus a negative. So when you figure it out, after you sub in, and make sure you use your parentheses, it's negative 6 minus negative 2. And a lot of students it kind of merges in their brain. When you sub in a negative number for B, and there's a minus in front of that, they just write down one negative, but it's actually 2 negative signs, or a minus and a negative sign. All right, on the bottom, C is 2, so I put it in parentheses. Because as I said, you can always write extra parentheses if you want to. It's not going to hurt anything. And now that's going to remind me that I need to square that before I make it negative. Okay? You have to square it because it's an exponent before you make it negative. I said that twice because it's extra important. All right, in the top, we have minus and negative. That's really plus and positive. So we have negative 6 plus 2 all over. 2 squared is 4, and that negative stays. And then what are we doing here? Get rid of that thing. We get negative 4 over negative 4, which is 1. So hopefully you got that, and you're happy and cheerful. Let's go to number 4. We have z minus the quantity y plus x squared. So I plug everything in. 2 minus quantity, negative 14, plus negative 4 squared. And I use parentheses again. When I square that, it should become positive because it's negative 4 times negative 4. That gives me a 16. Now I have to do inside the grouping symbols, or the parentheses first. That should give me a 2. So I'm going to get 2 minus 2. Wow. Even Bruss can do that. That's going to equal 0. So we're done with those types of problems. We're moving right along. We're going to talk about combining like terms. Well, first you have to know what a term is. Let's go through the following words to make sure we remember what they are. A term. Okay, a term is one part of an expression, and it only contains multiplication or division. So the 4x squared, that is a term. The y squared is a term. The x by itself is a term. The 5y squared, those are all terms, okay? Expression, when you put a bunch of terms together with pluses or minuses, that's an expression, okay? So it's this whole thing together is called an expression. A variable is the actual letters here. So the x is a variable, the y is a variable, okay? A constant, the constant's a number that doesn't change. We don't have any of those on here, but if I added here plus 22. All right, the 22 would be a constant. Constant is exactly what it sounds like. It doesn't change. It's constant. So that's why regular numbers, like the value of 22 is always going to be 22, no matter what. So that's why it's called a constant. Okay, these other terms, they have a variable with it. So depending on what the variable is, they could change. All right, the last term that we need to learn is coefficient. Those are numbers that are in front of the variables. All right, you're multiplying the variables by coefficients. So the coefficients here would be 4 and 5. That brings me to the next part, like terms. All right, talked about it before. Like terms are what you can combine. That's why we're learning that. Like terms have exactly the same number of each variable. So let's look for like terms up here. 4x squared, does it have any like terms? You can't say the x because there's 2 x's here and there's only a 1x here. So those are not like terms. And there's nothing else there. So you can't combine that with anything. Let's look at the y squared. Remember, that's really like a 1y squared. Is there anything else with a y squared? Well, yeah, right here. Okay, there aren't any x's, it has a y, and it has the same exponent. So these two are called like terms. If I wanted to, I could add them together to get a 6y squared. Okay, and what's left over, the x? Can I put the x with the x squared? No, they're different. They're different in terms of, they're different dimensions. Now, I don't want to get crazy on you, but that's like having a cube versus having a piece of paper. They're just totally different from each other. You can't do it. Nope, can't add them. Don't try it. All right, so now we're going to simplify using the distributive property. Let me back up a little bit, though. Do you see this little guy here? If you're not sure about this stuff, go to 2.4 in the algebra section, and you can freshen up. There's more detail there. Remember, I'm just reviewing. Okay, on to our feature presentation here. We have 5w minus 3w times the quantity 3w plus 6. So using GEMDAS, we can't add anything inside the parentheses. That's our grouping symbols. Exponents, we don't have any. Multiply and divide. We need to multiply first. So this distributive property thing has to go first. We have to distribute, and remember the way that we taught you was this 3 is really a negative 3. So it's negative 3w times the quantity 3w plus 6. So I have to learn my rules for exponents because we're going to do negative 3 times 3. That's easy, negative 9. But then w times w. Remember, there's really a 1 there and a 1 there. The rule for exponents is you add when you're multiplying. So that's going to give us w squared. W times w is w squared. Okay, we're still in the distributive property. We have to do negative 3w times 6. Well, negative 3 times positive 6 is negative 18. And then a w, that's w the first, times, okay, there's nothing there, so we're just going to hang out with the w. So we're almost done. Next part, we have to combine like terms. So you look at this, we got w's, we have w squareds. We can put the w's together. So remember when we have subtraction, that's really like a negative 18. We're going to do 5 plus a negative 18, or 5 minus 18. It's the same. That's going to be negative 13w. And then we have a negative 9w left over. Okay, sorry, negative 9w squared. And I don't feel comfortable unless I put the squared term first. It's okay if you don't. But I'm going to rewrite this so we have, this is a negative 9w squared, and this is minus 13w. Okay, so that's how we simplify the first one. That's the final answer. That's all simplified. That's beautiful. Now let's do the next one. We have negative 9. Have to do the distributive property, negative 3, and we have to do the distributive property. So that's going to give me negative 36, the first loop, and then negative 27b. So I write minus 27b. We have negative 3 times negative 7, that's a positive 21, and there's a b. And we have a negative 3 times positive 5 is negative 15. So now we'll combine like terms. Here's a regular old number, there's a regular old number. Here's a variable, there's a variable, they're the same, so I can combine the two green ones together. So what am I going to get there? I'll get a negative 6b when I combine negative 27 plus 21, that's negative 6. And then we have a negative 36 and a negative 15. Holy moly, that's going to give us a negative 51. So our answer there is negative 6b minus 51. And I can write it just like that. And I'm all done. So I'm going to pause the video. You do the next two. They're for you to practice. Go. Okay, hopefully these were no problems. You got to start off by doing the distributive property. And when you do that, I think that'll be no problem. Negative 15r squared, because it's r times r. And then we have minus 10r, and then the minus r that's hanging out at the end. That 5 doesn't go to that minus r because it's not in the parentheses. Now we have to combine like terms. The green part are the like terms. So we have a negative 10r and a negative 1r. That's going to give us negative 11r. Okay, so there's number 7. Number 8, if we're looking at it here, we have negative 4x times x minus 1. And we have a negative 1 here. So you have to distribute both. We get negative 4x squared plus 4x plus 1x minus 5x. Be careful those negatives there. We combine the two x terms because those are like terms, and we're all done with this one. Negative 4x squared plus 5x minus 5. That's enough about that. We're going to do a word problem. Mr. Bean drives a scooter. No, seriously, he really does. That's actually him there. The scooter currently has 8,200 kilometers on it, and he plans on driving at 36 kilometers per day. Write an expression for the number of kilometers Mr. Bean drives on his scooter over time. The reason I give you this problem is because you have a couple application problems with it, so we're going to make it real quick and easy. His scooter is starting with 8,200 kilometers. Okay, that's not going to change. That's what we have that right now. Actually, it is going to change over the next couple days. You're going to add to it. Okay, how much are you going to add? 36 per day. So I'm going to add a D there, and D stands for the number of days. Okay, the number of days. Please just don't write days. Okay, D equals days, because we don't know, like, what about the days? But the number of days. All right, so the expression here would be 8,200 plus 36D. That would figure out the total number of kilometers on his scooter over time. So you have a couple of those on the application. Just thought I'd throw one of those at you. Okay, so let's talk about least common multiple. That's the LCM, if you hear LCM. And this is taking you back to your 6th grade days or 7th grade. And what you have to do if you're not sure, a lot of you should be able to just do this in your head. But quickly, what you're going to do is you're going to list the multiples of each number. So we have 6, 12, 18. You're looking for the smallest multiple that all of them have in common. Okay, the least common multiple. Okay, so as we're doing this, you can list for each number all of the different multiples. All right, I'm going to quit at 30 there. Now look, if you notice something, 3, 6, 9, 12, 15, 18. First of all, 3 is a factor of 6. When you double 3, you get 6. So all of the numbers that are multiples of 6 are also going to be multiples of 3. So I really don't even have to worry about 3. I can just look for 6 and 5. The first number that is in common, that's the smallest number with both, is 30. Okay, so let's go through. Why don't you do parts B, C, and D, and we'll see how you do. Pause the video. Okay, hopefully there's no problem here. We'll start with B. You have 2, 3, and 5. So I'm looking at 3 and 5 because they're both odd. I gotta figure out you got 15 and then probably 30. 30 is even. That's a multiple of 2, so you got 30 for that one. Part C, you had a 1 and 2 in there. Well, I crossed the 2 out because I have a 4. All right, so 4 is a multiple of 2. So any multiples of 4 will also be a multiple of 2. All right, the 1 we don't really have to check because everything's a multiple of 1. And we're left with a 7 and 4. That'll give us a 28. And for D, the last one, did you notice that 12 times 2 is 24, 8 times 3 is 24, and 4 times 6 is 24. So 24 will do it for us. We're done with LCM. To the next part we go. Okay, so why then, might you ask, do we have to learn all this LCM thing? Well, tell you what. It has to deal with these ugly fractions here. And I know you guys hate these fractions. So what I've done is I've given you the LCM. Okay, next lesson you're going to have to come up with it by yourself. But the way you do that, you look at the bottom of the fractions here. We have a 3, 4, and 6. So the least common multiple there is a 12. So for this lesson, I've put it there for you. But what we're going to practice is multiplying through this least common multiple to each side here. Then we're going to simplify it. In the next lesson, we're going to actually solve those equations. So let me show you how to do this in your head quickly. Okay, remember this 12 is like 12 over 1. As I multiply through, I'm going to get this. All right, the first one I'm going to get 12 times 2/3. Well, every time if you use the least common multiple, the denominator will cancel with a 12. So that 3 will cancel with a 12 and it'll leave a 4. All right, well then I just have the 2 on top. 4 times 2 is 8. So when I multiply 12 times 2/3 x, I get 8. Don't forget the x. All right, let's try that again. I'm going to erase this little side stuff we have here because that was only for the first term. We'll come back to it. We have 12 times negative y. That's easy. I don't need to do any math for that. All right, 12 times negative 1/4. The 4 will cancel with the 12 and leave a 3. 3 times 1 will give you a 3. Okay, and we're all done with that one. Let's try the last one. 12 times 5, 6x. Okay, the 12 and the 6. I'll actually write on this now because they cancel. 12 and 6 cancel. It's my last one here. Leaves a 2. So now I have 2 times 5x is a positive 10x. See how easy that is? So now I can combine like terms. So that'll give me 18x. This will give me a negative 15y. That's going to be my simplified final answer for number 9. Let's try number 10. All right, with number 10, we have an LCM of 15. And again, I gave that to you. Let's multiply through. I'll talk you through each of the terms. The first one here, we have 15 and 3. That cancels and leaves a 5. 5 times 1y is 5y. Done with that. 15 and the 5 cancel, and it leaves a 3. All right, 3 times negative 3 is negative 9x. All right, so what are we doing here? I'm going to get rid of that so we're not confused. Okay, so 15 and the 3 here cancel, leaves a 5. So 5 and negative 2y will give you negative 10y. See how you can kind of do this in your head? Those 15s cancel, leaves a 4x, and you're all done here, and then you can simplify. All right, so here's what you... Let's combine like terms. Come on, let's finish the problem. Kelly, finish the problem, Kelly. Let's finish, let's go through here. why don't you pause the video, do 11 and 12, set, go! Okay, so let's look at number 11 here. Is if I multiply through 21 times 4x, that's 84x. 21 times 4 is 7. 7 cancels with a 21, leaves a 3. 3 times 4 is 12. We get 7 times 13. Had to work that out up here. It's 91. 21's cancel, you're left with a 20x. Simplify, you get 104x minus 103y. Hopefully that didn't go too badly for you. And number 12, the LCM here is 24, so we multiply through. Okay, you cancel, you get an 8 times 2 is 16. We get, they're going to cancel, give you 6 minus 3. That's going to give you a negative 18x. And what do we get? 3 times negative 2 is negative 6. And lastly, we get 4 times 5 is 20. Combine like terms, and we get 2x plus 10y. Done with that goodness. Hey, that's it for me here. This is Mr. Kelly and Bomb Holder. Remember, you want to be honest with yourself. Make sure you know how to do this before you take the mastery check, because you do not want to fail the first one of the year. That sends the teacher and everyone else the wrong message. Hey, this is Mr. Kelly. As I said, I'm in Bomb Holder. Remember, it's nice to be important. It's more important to be nice. See ya.